All right, I hope you tried it first, but here is the solutions to the study guide. When you name a polynomial, you can name it by its degree. So in this case, the largest exponent, so that's a cubic. You can also name it by how many terms there are. And you can put it together. So the greatest exponent is 3. There's 3 terms. We call that a cubic trinomial. Same thing here. The degree, the biggest exponent is 2. We call that a quadratic. There are 2 terms. We call that a binomial. If I want to know the end behavior, I have to know the power term. That's not just the greatest exponent, but also the sign in front. So if I see the power term, that's negative x to the 5th. What does that tell me? So a negative power term means it goes down to the right. An odd exponent means it goes in the opposite direction. And then how do I write that? So as x approaches infinity, the function goes down. As x approaches negative infinity, the left end behavior, the function goes up. So again, I'm going to identify the power term and recognize it's positive and even. So that means both ends go up. So we write down as x approaches infinity, the function goes to infinity. As x goes to negative infinity, the left end, the function also goes up. So both ends go up. Again, identify the power term. It's negative x cubed. So that means the right end goes down, left end up. It's negative with an odd exponent. And we write that through. One more here, x cubed, that is positive with an odd exponent. So that means the right end goes up and the left end goes down. All from the power term. All right, do you remember how to divide? This is a simple divisor. So we can take the 0 or the opposite number and do synthetic. So we have 2x cubed, negative 2x squared, negative 32, and negative 18. Remember, if there's a power that's missing, you have to put 0 in that place. If you want, you can create columns, drop down the first number, and then we multiply. So negative 3 times 2, and then add a negative times a negative is positive, then add a negative times a negative is positive, and then add it up. And then the end answer, your answer is going to be 1 degree less than what you started with. So it's going to be 2x squared, then minus 8x, then minus 8, and then the remainder is written as a fraction over the divisor. Same thing here. We have negative 9, so be careful about that. And we have 1, 8, negative 13, and negative 40. You can create your columns if you like. Drop down the 1, and then multiply, and then add. And then you have the remainder. So it's, again, 1x squared minus 1x minus 4, and then the remainder is 4 over the divisor. Here, this is not a simple divisor, so we have to use long division. And when we use long division, we're just dividing the power terms of the dividend and the divisor. So if I go 7 divided by 7 and x cubed divided by x, I end up with 1x squared, and then I distribute. So x squared times 7x, x squared times negative 9, and then subtract. Now, when you subtract the negative, be careful here. These will always cross out the first column. So this is actually adding, and you get 35. Then divide again, 35 divided by 7, x squared divided by x, and then distribute. And you bring down the next term. So that's 35x minus 45. When you subtract the negative, you're adding, if you need to, 108 and 45. We can do this on the side. You get 63. It's going to be negative 63. Bring down the last term, which is 79. Divide. That's negative 9. Multiply. And then subtract. Remainder. Remember, your remainder is written as a fraction over the divisor. And you have your answer. Number 10, we have long division again. Be careful if you have a missing power, which we do. We have no x, so we make sure we put a 0 there for what's missing. Divide, I got 1x squared, and then distribute. This is no remainder, no x. So the only thing left is negative 4. So we have 0, 0, and then minus 4. So really the remainder here at the end is just this. When your remainder is less powerful than what you're dividing by, that's your remainder. So that's minus 4 over 3x minus 7, and it's done. These are all factorable. Can you find zeros by factoring and then label the zeros rational, irrational, or complex? So this is a diamond. So two numbers that multiply to negative 24 and add to 2 are positive 6 and negative 4, but it's going to be x squared plus 6 and x squared take away 4. That way when we multiply them together you get x to the 4th and you get the middle term of x squared. Then we take each factor equal to 0 and solve it. So the first one, when you solve, subtract 6. When you square root a negative number, it's imaginary and the square root of 6 is irrational. Again, we're going to add 4 and square root. Here when we square root 4, it's 2 and it's both positive and negatives. And then we label them. So these zeros are complex and these are rational when you know the exact value of them. We have 4 terms. So we're going to factor this by grouping. So we're going to look at the first 2 and factor out x squared. Then look at the last 2 and factor out negative 1. Make sure 2 negatives make that positive. So the factor they both share and what's in front of each one. If you like, you can factor out x squared subtract 1. That's a difference of squares. And you don't have to make it equal to 0. Like each one you could see, the 0 is the opposite number to the factor. So we have zeros of negative 2, negative 1, and positive 1, and all of these zeros are rational. Number 13, again, we're going to factor out. First, I'm going to factor out a common factor. They both all have an x, so we factor that out first. And then after you factor out an x, then you can factor by grouping inside. So the first thing I notice is x squared. Then positive 4. So I have x, x minus 4, and then x squared plus 4. So if we're talking about the zeros again, x, that's 0 is a 0. That's positive 4, because positive 4 take away 4 is 0. And then x squared plus 4. If we need to, by the way, these are rational. If we need to go x squared plus 4, make it equal to 0 and solve it, we can. Subtract 4. When you square root a negative number, it's imaginary. It's positive and negative, and the square root of 4 is 2. So it's positive and negative 2i. We call those complex zeros. All right, last one. No common factor. It's a diamond. So two numbers that multiply to 35 and add to 12. Again, we're going to use x squared. So x squared plus 7, x squared plus 5. Both of them equal to 0 and solve both of them. So I'm going to subtract 7, and then when I square root, the answer is positive and negative. And the square root of a negative number is imaginary, and you have root 7. Same thing here. We're going to subtract 5. And then when I square root, the answer is positive and negative. It's I, because you're square rooting a negative number, and then root 5 is irrational. Both of these are, all of them are complex. All right. Can you evaluate doing synthetic division? So synthetic substitution says instead of plugging in negative 6 and doing it the old-fashioned way, we can divide to evaluate. And when you divide this case, the number you see is what you're dividing by. So I can divide, and then the remainder is the answer I'm looking for. So again, I'm going to go 4, multiply, and that's the answer I'm looking for. So if I say, hey, what's f at negative 6? The answer is the remainder. Same thing here. Instead of substituting in, I can divide to get the answer. That's called the remainder theorem. Be careful you don't have any missing powers. You can create your columns. So that's negative 3 negative 15, negative 5, 3, and 15. So again, the answer is the same. So f at 5 is equal to 12. So again, we divide the remainder is the answer I'm looking for when you divide the remainder. That's called the remainder theorem. Next skill is, can you write a polynomial function if I give you the zeros? So step one is to create it and then to FOIL it out. So to create it, it's the denominator first, opposite, and then the numerator. If it's just 5, it's the opposite. Again, it's the denominator, the opposite, plus, and then the numerator. So now we've created factors out of these zeros. Pick whichever ones you want. There's no shortcut here. So I'm going to take the first two. You could take any order you want. So 4x and 3, x minus 5. We're going to multiply it out by foiling. We're going to combine like terms. And that answer is going to go here. That's now going to be 2 by 3. So I need a little bit longer of a box. So this answer is going to go on top, which is 4x squared minus 17x minus 15, and then 3x and 1 on the side. And again, we're going to multiply it out. This is going to give you your final answer. That's cubed. 17 and 3, what is that? 30, 20, 51. Negative 45. This is easy, right? 4x squared minus 17x minus 15. All right. Then, when I put it all together, we have 12x cubed. We have negative 51 plus 4. That's negative 47. Negatives mean you add them. That's going to be 62. And then minus 15. All right, let's do the same thing here. We're going to create the factors here. So not complicated. Plus 4 minus root 6 plus root 6. If I have opposite zeros here, so the same number, but one's positive, negative, and one's negative, I'm going to focus in on that one first. So this order will make it simpler to focus on those two numbers. So if I go x minus root 6 and x positive root 6, I'm going to multiply that out. The middle terms are going to cross out because of that. So positive x root 6, negative x root 6, they're going to cross out. Root 6 times root 6 is just 6. So if I put it together, I just have a binomial. That's what makes it a little smaller. So that's x squared subtract 6. And then I'm going to multiply by x plus 4. And then I'm going to FOIL, and you'll get your answer. No like terms here. So our final answer, going from the greatest power to the least, is x cubed, then positive 4x squared, then minus 6x, then minus 24. All right, try again to write a polynomial here. So as factors, that's going to be x plus 5. That's x subtract I. That's x plus I. Again, I'm going to focus on what's a difference of squares, because I know the middle term is going to cross out. So if I focus on that, I know these right here, the negative xi and the positive xi, they cross out. That's negative I squared. So this again is a binomial. I need to remember that I squared is equal to negative 1. So this is really x squared minus negative 1. So this is x squared negative, and then you plug in negative 1 for I squared. So altogether that's x squared plus 1. And then on the side I'll use x plus 5 and then finish the multiplying. So that's x cubed plus 5x squared plus x plus 5. Okay, I'm going to focus again. If you want, that's minus 4 plus 2i and minus 2i. If you want, you don't even have to FOIL this. Like, I recognize this is a difference of squares. So you just go first times first, that's x squared. Last times last, that's negative 4i squared. I'm going to remind myself that negative 4i squared is positive 4, because I squared is negative 1. And then draw and FOIL. So this one we would have to FOIL. So we have x squared plus 4. And then x minus 4. So remember that this turned into positive 4. and then multiply it out. There's no like terms again. So your end answer from most powerful to the least powerful is x cubed minus 4x squared plus 4x take away 16. All right, sometimes things aren't factorable, and if I want to find all the zeros, I got to create a list. So in this case, the list, I think of the last number, which is plus and minus 1 and plus and minus 5. This one actually has a beginning number, that leading coefficient that's not 1. So all the numbers that go into the first number, that beginning number, are 1 and 5. So that creates fractions. You divide. Now if you divide by 1, that's fine. But we're also going to divide by 5. So if I divide by 5, 1 divided by 5. Now 5 divided by 5 is 1. So that's your complete list. I am not going to start with a fraction. I hope that one of the other numbers that aren't fractions would work. Now I can give you one shortcut that I've told you before. Can you add the numbers? Do they add up to 0? And you can see that 5 and negative 5, negative 31 plus 31, it does add up to 0. Positive 1 works. So we're going to use positive 1. And then what's left, I hope I can factor. So I have 5x squared minus 26x plus 5. So the first number times the last number. And so there are two numbers that multiply to 25 and add to negative 26. Be careful to divide after we do this. That means we're going to divide by the first number, which is 5. So if I put this all together just to find the zeros, so we have a 0 at positive 1. We have one at positive 1 over 5. And then when I divide, I have one at positive 5. And I found all the zeros. That's what my goal was. Same thing here. We're going to create a list. Very similar. So it's positive and negative 1, positive and negative 3. That beginning number is 3. So we divide by that to create other numbers that may not be on my list. So if I divide by 1, if I divide by 3, I get 1/3. If I divide by 3 by 3, I get 1, which is already on my list. So there's my complete list. Positive 1 does not work because it does not add up to 0. So we need to try another number on the list. So maybe 3 works. So we're going to try 3. 30, 42. It's not going to work. So 3 didn't work. It's fine. Let's try negative 1. That's 3. That's negative 2. That didn't work. Oh. Did I miss a power? 3, 5, negative 11, 3. 3 didn't work. Well, why didn't 3 work? Why didn't I no, because 3 times 14 doesn't work. Wait a second. Did 1 work? Like if I added this up, does it add up to 0? The answer is yes. So I'm just being silly. So let's if you make a mistake, don't admit it, move forward. But so 3 plus 5 take away 11. It does. Positive 1 does work. And I'm running out of space because I did that. But that's negative 3. That's 0. So I'm left with 3x squared, 8x minus 3. So I'm going to do that up here. The first number times the last number. So the two numbers that fit here are positive 1 and negative 9. So wait a second. That's negative 9 and positive 8. So this is positive 9 and this is negative 1. Okay. And then you got to divide still. So I have x plus 9, x minus 1. Divide by 3. And I just barely have enough room here. So 1, this is garbage. So there, positive 1 worked. 9 divided by 3, the opposite sign. 1/3, the opposite sign. And so the numbers that worked were 1, negative 3 and 1/3. The numbers I didn't use. Man. All right. Well, there you go. 23. These are rationals. Can you factor to simplify them? So the first number times the last number, those two numbers are 1 and 35. And don't forget to divide. In this case, you're dividing by 7. And then come back to the question. So 1 over 7 can't simplify, so that's 7x plus 1. Slide the denominator in front. 35 divided by 7 is 5. When I look at the denominator, factor out the common factor, which is 4x, and you're left with x plus 5. Cross out the common factor, and that's it. You've answered it. Again, we're going to factor out a 10p. The denominator we're going to factor. The first times the last, that's 30 and 11. That's 6 and 5. And again, we're not going to forget, that's p. We're not going to forget to divide by 5. So when I divide by 5, on the bottom, I got p plus 1. This slide the denominator, 5p plus 6. P plus 1 crosses out, and your end answer is 10p over 5p plus 6. Here again, we're going to factor. So in this case, the largest one I think is it 6? Yeah. So factor out 6x. That's 3x plus 8. Factor out, same thing, is 6. That's x plus, that's 3x plus 8. The denominator, two numbers that multiply to 120 or 10. I'm not going to write it as squared. I'm going to make sure there's nothing that crosses out first. At the end I could if nothing crossed out. So 3x plus 8, 6. And so what I'm left with on top is 6x and 3x. On the bottom is x. Oh, I can cross out the x's too. So cross these x's out. Let's try it again. So at the top, only thing I didn't cross out was 6. And on the bottom, I have x plus 10, which I can then, at the end, I can write as x plus 10 squared. All right, factoring again, factor out a 5 and an x. That's prime, this is prime. Factor out a 5x, dividing. And then what you can match and cross out. That leaves me with 70 on top and x plus 3 on the bottom. 27, factor out 12, that's x plus 5. Factor out a 6, that's x plus 7. When you divide, change it to multiplying and flip, so the bottom will go on top. So factor out the 5, that goes on top. This top goes on the bottom, factor out 2, and then look to match. So the x plus 5 crosses out. 2 goes into 12, 6, and the 6's cross out. So all I'm left with that I didn't cross out is 5, x plus 10, and on the bottom is x plus 7. Again, I'm going to factor this. This is 30, first number times the last. That is negative 10 and negative 3. Make sure you remember to divide. I'm going to divide by 6 and reduce it down. Then you can slide the denominator. So the first one is going to be 3x minus 5. And the second one is 2x minus 1. Make sure you change it to multiplying. Then I'm going to flip this one. So that denominator, I'm going to factor out a 5, but it goes on top. Factor out a 7, but that goes on the bottom. And then cross out what you can. What you didn't cross out was 5x minus 9 over 7. All right, simplify this. Now, we need to have common denominators, so I'm going to factor first, and then look, what do I multiply to make the denominators the same? So you can see, looking at the denominators, it needs an x plus 3, top and bottom. So I have x plus 5, and then I'm going to distribute. Think of it as negative 6x. So if I distribute, that's negative 6x squared, and a negative again is negative 18x, and then combine like terms. So that is negative 6x squared. That is negative 17x plus 5. You don't have to distribute the bottom. If it's not factorable, then I have to use the other denominator to make common denominators. So I'm going to use x plus 5, top and bottom. I'm going to use x minus 6, top and bottom. And now that the denominators are the same, I can distribute. That's 2x plus 10. That's 3x minus 18. And then combine like terms. So that is 5x minus 8 over the common denominator. Here, when we have complex fractions, we need one fraction over one fraction. So that's good on top. Here, to make it 1, we're going to multiply by x squared, top and bottom. The second one stays the same. So I have 1 over x, and on the bottom I have x cubed plus 2 over 2x squared. Now, I keep the first, I change it to multiplying, and now I flip it. So the x makes the x squared just an x, and so if I multiply the tops and the bottoms, you end up with this answer. So again, my goal is to make one fraction on the bottom, so I need common denominators. So I'm going to multiply by x, top and bottom. And I'm going to multiply by 3, top and bottom. That way, those denominators are the same. So I have 3x squared over x squared. I have 2x squared minus 18. And now, the first one I keep, change it to multiply, and then I flip. And see, is there anything that I can cross out? So the x squared and the x cross out, make that x. So I end up with 9 on top, and then x, 2x subtract 18 on the bottom. So even if I factor out a 2, it's not going to simplify with anything on top. All right, we're going to solve these equations. First thing I'm going to do is what can x not equal? So x cannot equal 0, or that would make it undefined. And now I'm going to make the denominators the same. So the first fraction I'm going to multiply by 3. The second one times 3x, top and bottom. And then the last one's perfect. It's already 3x. So now all the denominators are the same. Now write only the numerators. And then you solve it. So I'm going to subtract 1, divide by 3, and I have my answer. And it's a good answer because it's not restricted. So again, I want common denominators. So first step, I'm actually going to factor out an x and see what do I need to do to make them the same. So the first one needs an x minus 5, top and bottom. And the last one needs also an x minus 5, top and bottom. Now, the denominators are the same, so I just write the numerator. So 1 times x minus 5 plus 1, and then distribute, which is 5x minus 25. Then solve it. So we're going to subtract x. I'm going to add 25. So all of these numbers are going to add. That 25 plus 1 is 26. Take away 5, that's 21. Then divide, and you have your answer. What were the two answers x cannot be here? So it cannot be 0, and it cannot be 5. So that is a good answer. Again, we're going to solve. So we're going to first factor. And then how do I multiply to make the denominators the same? So I'm going to factor out an x. So to make them same, the first one needs an x minus 6, top and bottom. The second one needs an x, and the last one is good. So I'm just going to write these out. Now, as I write it out, to save a little space, I'm going to FOIL the first one. So x minus 1 and x minus 6, we're going to multiply it out. That's x squared minus 6x minus 4x, no, minus 1x. Plus 6. So if I combine like terms, just the numerator, it's x squared minus 7x plus 6 equals x minus 1. Make it equal to 0, so I'm going to subtract x. That's minus 8x. I'm going to add 1. That's 7. And then that's what I'm going to factor. So two numbers that multiply to 7 add to negative 8 are negative 1 and negative 7. And those are my answers. So it's positive 1 and 7, the opposite numbers to that. What could x not be? So I'm going to write that down. It couldn't be 0 and positive 6. So those are two good answers. Done. All right, last one like this. We're going to factor out an x. And then we're going to multiply to make the denominators the same. So the first one needs an x, and the second one needs x and x minus 3. Now all the denominators are the same, so I have 4, I have 6x, and then if I distribute here, that's x squared minus 3x. I'm going to make sure the order is good, so I'm going to put x squared. 6 take away 3 is positive 3x, and I'm going to subtract 4, make it equal to 0, and then I'm going to factor it. So the two numbers that multiply to negative 4 and add to 3 are 4 and negative 1. And then my solutions are negative 4 and positive 1. If I look here, what can x not equal? It's 0 and positive 3. So both of those are good answers. All right, last part here. Radicals. Can you simplify a radical? So 54 is 9 times 6. X squared is perfect. The square root of 9 is 3. And the square root of x squared is x. And what's left over is 6. So if I put it all together, I have negative 6x, the square root of 6. 75 is 25 times 3. X to the 5, if it's an odd exponent, the greatest even exponent that's less than 5. And we need 1x, they add up to 5. And then the square root of 25 is 5 times 5 in front is 25. X to the 4th, the square root is x squared. And then what's left behind, so I took care of that, is just 3x. Add and subtract, we got to simplify first. So 24 is 6 times 4, 27 is 9 times 3, 24 again is 6 times 4. So the square root of 4 is 2, times 2 is 4 root 6. Square root of 9, 3 times 2 is negative 6 root 3. Square root of 4 is 2, times negative 2 is negative 4 root 6. Or root 6. Then positive 4 root 6, negative 4 root 6, cross out. There's no like terms here, so the end answer is just negative 6 root 3. All right, we're going to do this again. Root 24, again, is 4 times 6. 54 is 9 times 6. So we're going to simplify it first. So the square root of 4 is 2, times 3 is 6 root 6. Square root of 9 is 3, times 3 is 9 root 6. So this is 6 take away 9, which is negative 3, take away 1, which is negative 4 root 6. All right, root 6 and root 8. 8 is 4 times 2. Square root of 4 is 2, left over. So these are unlike. So, we're multiplying them together. Let's try that again. Not adding. So it's still good to simplify it first, but I'm multiplying. So that's 2 root 2. So if I multiply it, it's 2 root 12. Square root of 12, I'll do that up here, is 6 times 4 times 3. So the square root of 4 is 2 times 2. So the end answer is 4 root 3. All right, let's try it again. Simplify it. Square root of 8 is 4 times 2. Square root of 4 is 2 times 2. That's 4 root 2 times root 6. Feels similar to the last one. And then 12 is 4 times 3. So your end answer is 8 root 3. So the square root of 4 is 2 times 4 is 8. This is going to be a FOIL. We're going to multiply it out. Root 5 times root 5 is 5. This is negative 2 root 5, negative 3 root 5, and positive 6. So altogether, 5 plus 6 is 11. Negative 3 and negative 2 is negative 5. And I have my answer. Again, this is a FOIL. Make sure there's plenty of space here to FOIL. We have negative 3, 4 root 3, negative 3 minus 5 root 3. And then we multiply it out. So a negative times a negative is positive 9. This is negative 12 root 3, positive 15 root 3. This is negative 20 times 3, which is negative 60. So 60 take away 9, that's negative 51. And 15 take away 12, that's positive 3. And I have my answer. So negative 20 times 3 is negative 60, just so you know. So negative 60 and 9 make negative 51. We're almost there. 45. Dividing, 30 divided by 10 is 3. 15 divided by 3 is 5, and you have your answer. That's prime. To divide here, I need to do the conjugate. So instead of 2 subtract, it's 2 plus root 5, top and bottom. So the numerator becomes 8 plus 4 root 5. You distribute. Here, 2 times 2, and root 5 times root 5. So altogether is 8 plus 4 root 5. You could also divide negative 1 to make it negative 8 minus 4 root 5. Both are good. All right, can you write this as an exponent? So the base is 6r, the denominator is 3, and the power is 4. Done. Write this as a radical. The denominator is cube root of 6x. There is no power of 1 we don't even put down. How do I simplify this? So I write it as a radical. That's the cube root of 27 to the power of 2. So the cube root of 27, what number 3 times itself is 27. Then square that answer, and you have the answer here. 5 over 2, that means the square root of 4 to the power of 5. That's 2 to the power of 5, which is 32. All right, solving equations. To solve a square root equation, we're going to square both sides. So that's 3 minus x equals 4. And then we're going to solve it. So I would add x, I would subtract 4, and you get your answer. Be careful that when you plug negative 1 in, a negative times a negative, that makes positive 4 equals 2, so it's a good answer. But you really have to double check to make sure it's not extraneous. Here we're going to square both sides. That's 3x minus 2, x minus 20. To solve for x, I'm going to subtract x. I'm going to add 2. So these cross out. And then divide by 2. So I get the answer x equals negative 9. When I plug in negative 9, like if I go 3 times negative 9 take away 2, that gives me a negative answer. So that's bad. So that means there's no solution. We call that an extraneous solution, a restricted answer. Here we're going to square both sides. When you square a square root, they cross out. So it's just x plus 2. We're going to make it equal to 0. So we're going to subtract x and subtract 2. We're going to factor it. So two numbers that multiply to negative 2 and add to negative 1. So that's x minus 2 and x plus 1. So two answers to test are positive 2 and negative 1. Negative 1 is a bad answer because the square root of any number can never be negative. So that's extraneous. 2 does work. So the only answer is x equals 2. All right, again, we're going to square both sides. So that gives me x minus 5 squared is equal to 13 minus 2x. I get a FOIL. So that's x minus 5, x minus 5. Multiply it out. combine like terms, I get x squared minus 10x plus 25. Then we're going to make it equal to 0. So I'm going to add 2x to both sides. That is negative x. I'm going to subtract 13. 25, take away 13. It's 12. Again, I'm going to draw a diamond. Two numbers that multiply to, I picked the wrong one, 6 and 2. Negative 6 and negative 2, multiply to 12 and add to negative 8. Solve it. So that's positive 6 and positive 2. Test it. 6 is good because 6 take away 5 is a positive value in here. But 2 is bad because 2 subtract 5 is negative 3. And the square root of a number can never be negative. That's extraneous. So we only have one answer. Graphing. And then we're done. Do you remember how to graph a square root? So A is negative 2, H is 3, and then K is negative 5. Sorry, let's try that again. A is negative 2, H is negative 5, dear me, and K is 3. Positive 3, what it says. We start with the point 0, 0, 1, 1, and 4, 2 for a square root. To the x's, I'm going to subtract 5. So subtract 5 to every x value and write the answer down. To the y coordinates, I'm going to multiply and then add 3. So 0 times negative 2 plus 3. 1 times negative 2 plus 3. 2 times negative 2 plus 3. And I'm going to put those points on the graph. So negative 5, 3. Negative 4, 1. And negative 1, negative 1. You can see what direction it's going. It's going down to the left because A is negative. There's a reflection. The domain starts with your h value. So it's negative 5 to infinity. The range goes from the bottom, which is negative infinity, up to the k value, which is 3. And then the end behavior, the right end goes down, and the left end goes to h and k. That's negative 5 and 3. All right, we're going to try that again. I'll do better here. A is 4, h is negative 1, and k is negative 5. So the points are 0, 0, 1, 1, and 4, 2. We're going to subtract 1 to every x value, and then we're going to multiply and then subtract 5. So 1 times 4, take away 5. 2 times 4 is 8, take away 5. And then those are going on the graph. So negative 1, negative 5, 0, negative 1, and then 3, 3. And then we're going to curve up to the right. And then the domain is your h. That's negative 1 to infinity. Your range, the bottom is k, which is negative 5 to infinity. And then the end behavior. So the right end goes up, and the left end is the point, hk. That's h. That's k. We got this. All right, cube root. So for a cube root, we're going to start the same way. So a is 2, h is positive 2, and k is negative 1. For a cube root, it's 0, 0, 1, 1, and negative 1, negative 1. So again, we're going to add 2 to every x value. And then to the y value, we're going to multiply times 2 and subtract 1. And then we're going to put those points on the graph. So 2, negative 1, 3, 1, and 1, negative 3. And they line up. We're going to curve up to the right and curve down to the left, just like a long S. The domain and range are always all numbers. And the end behavior. So the right end goes up and the left end goes down. All right, last one. And you did all the content work practicing for your exam. So again, we're going to start with AHK. So A is negative 1, H is negative 1, and K is 5. We're going to write down the points 0, 0, 1, 1, and negative 1, negative 1, and change the points and put them on your graph. So the x values, we're going to subtract 1 all the way down. To the y values, we're going to multiply and then add 5. So 1 times negative 1, and then add 5. Negative times the negative positive 1, add 5. Those are the points that are going on my graph. Negative 1, 5, negative 2, 6. And what did I forget? 0, 4. So we're going to go down to the right and up to the left. So there's a reflection there, so the S has been flipped around a bit. The domain and range are always all real numbers. And then the end behavior. In this case, the right end goes down and the left end rises. That's it. Mr. G Math over and out. Good job getting to the end of this and checking your work, getting help if you need it. And I really want you to do well in the exam, all right? Until next time.